Hi folks, and welcome to today's video, which is an unboxing video. It's another unboxing of another second-hand Zuma Hedgiez. This one cost me £6.18. So I've got this for a project. Some of you may know that the two Hedgiez you can see on the screen were part of a project we did to put different coloured LEDs in the eyes, and that worked out really well. Be interesting comparing this one that I'm opening today with the other two, because it's got the original green LED eyes, so it'd be interesting seeing the contrast. But this one is going to be a much more extensive project, and I'll tell you all about it once I've got this out the box, checked it over, see if it's working all right, and compared the eyes with the other two. So without further ado, let's get it out the box. And here it is. As you can probably tell, it's the same styling as this one. Nice little note the eBay sellers put in with it. I don't expect this to have batteries in it, but I'll try switching it on anyway, just in case. No, it hasn't got batteries in, but I would have been very surprised if it did have, seeing as it only cost £6.18. So the first thing to do is open up the battery box, check that that's okay, and put some batteries in, see if it's working. Battery box looks okay, and the contacts on the battery door look okay. Okay, we'll try switching it on. And it's not working. Okay, so I'm going to take the batteries out of this one that I know are definitely working, just in case the batteries have got a dicky. So I know these batteries are definitely working, and I've definitely put them in the correct way, so let's see. Yes, must have been the batteries. So you can see what they look like now with the different coloured eyes. These are the original eyes. You can't really tell on the screen, but the green. And those are the LEDs that we swapped in this one, which are pink. And certainly in real life, the pink ones are much more attractive. So the new one's in very good shape, because I actually took the cover off this one and washed it. But this one just doesn't look dirty next to it at all, so I don't think it's being used very much. It does look like, though, that with these, the material was just cut randomly, because this one's quite attractive because they've got the circles neatly in the middle on the back, whereas this one's a bit of a mess really. They've not matched it at all. But that doesn't matter, because as well as doing an electronics project with this one, I'm also going to do a radical custom on it, which includes changing the fur. So now I'll tell you about our electronics project that we've got planned for this. So what we're going to do with this one is we are going to replace the switch in the nose with a microphone module. What we're hoping is to get the same functionality by using voice as you will get from pressing the nose. So it differentiates between a short press and a long press. So what we're hoping is that making a short sound will be interpreted as a short press, and making a longer sound will be interpreted as a long press. So this is the module, isn't it, Paul?
Yeah, this is the microphone module. There's the microphone. This is the adjustable sensitivity. And this wire is the digital output, which is either on or off, depending on how much sound the microphone picks up.
And then the black and the red's just to the battery.
It's just picking up a bit of power off that breadboard at the moment, yes, but it will be from the battery in the Hedgehog.
So it says down the side ground for the black wire. So then we've got VCC, and that's the positive supply.
Yeah.
So we've got DO down the bottom there that the yellow wire is plugged into. So that's digital output.
Yeah, it's either on or off, depending on the level of sound that the microphone senses. And you can see the module is very small, so we should have no problem locating it somewhere in the Hedgehog, and picking the sound up from outside.
Yeah, it's only about just over 1 inch long, isn't it?
It is, yeah.
So this digital output pin and this wire,
yeah,
you're not sure yet how that is wired into the switch?
The nose the switch on the nose that goes back to the circuit board. I'm not sure how it's wired into the circuit board yet. Yeah.
I've got to disassemble the Hedgehog.
That's right, and then I can take a few voltage readings
with the multimeter.
With the multimeter around the circuit board where currently the Hedgehog nose switch plugs into, so I can figure out how to connect this in properly.
So Paul's powering the microphone module up now.
Yeah, one light is the power on, and the other means that the digital output's triggered. So at the moment,
so the sensitivity's turned right up at the moment.
It's too high at the moment. That's why the output's on.
Yeah, like permanently.
Yeah. So yeah, I've got to turn the sensitivity down until the digital output light just goes off.
Yeah, it's
just gone off. Just back on again, and it's off. So that should be fairly sensitive now. Testing. 1, 2, 3. So every time that light comes on, even if it's just a little flash, it's been triggered. And that would be the equivalent of pressing the nose switch on the Hedgehog.
Short press, we think.
A short press, yes, because the Hedgehog can differentiate between a long press and a short press. How long is the long press on the Hedgehog?
Not long, just about 3 seconds, I think.
So with this device, this sound module, to make the Hedgehog trigger the Hedgehog as though the nose switch had been pressed for 3 seconds, we'd have to make a noise something like whoosh for 3 seconds.
Or maybe try a whistle.
Oh yeah.
Oh, that's fun.
For 3 seconds. I'm not quite sure how it would work, the long press, but certainly we should be able to set it up so it triggers it on the short press.
Now, we're still flashing there, so that might be
short. I mean, that might be multiple short presses. So we might have difficulty triggering it for a long 3-second press. But
it's experimental.
It's experimental, yes.
So we've got the Hedgehog disassembled now. And this is the nose switch, which goes here on the circuit board. So you're going to take some readings with the multimeter, Paul.
Yeah. Just take it out first. I suppose it's a push to make switch, but we'll just verify that. So it's a push to make switch.
So you attach the crocodile clips to those 2 soldered points there that are labelled P1 and P2. Yeah. What are they?
They're where the ends of the wires are soldered into the switch. They're the output to the switch.
They're where these 2 wires are soldered to the switch. Right.
So underneath that little rubber cap is a switch. And effectively you've got 2 contacts like that.
Yeah.
And when you press, it closes them.
Right.
And when you release it, it opens them.
So you were just making sure that when you pressed it...
They closed.
Yes.
Because some switches you get all like that to start off with, and when you press it, it opens them.
Ah, right. Okay.
And what I'm going to do now is use the multimeter to measure voltage at various points to give me an idea what's going on the circuit board. That's reading virtually nothing. and that's reading 3.2 volts. So this is a nose switch, and when you press it, it closes the switch. So it shorts the green wire to the blue wire. So it's like a logic signal that's been sensed by the board. And normally logic signals are sort of held high by a resistor, and when you press the switch, it grounds the input. So it goes from whatever voltage it is when the resistor holds it high to 0 volts, and that's sensed by the circuit as the switch being closed. So what I was doing, I had to establish which side of the wire was ground, and it turned out to be the blue wire. When I say ground, the negative side of the battery.
Mm-hmm.
And the other side is what's got to be, the green wire is what's got to be connected to ground to represent an input. So now we know that information, we're able to connect it to the output of the microphone module.
Right.
So the output of the microphone module, the digital output,
which is the yellow
wire on our board, is what's called the collector of a transistor. And when the microphone is activated, when you speak loud enough and it activates it, it turns that transistor on. And
right.
the collector is then open, and whatever's connected to it is shorted to ground. So the transistor's acting like an electronic switch.
Oh, that's interesting.
It's just either on or off.
But
it's an electronic switch, is operated by sound.
Mm.
I was measuring the voltage on the blue wire and the green wire with respect to the negative side of the battery, or the ground, because that's the way it's normally done in circuits. And we found out that there was a substantial voltage on the green wire and virtually no voltage on the blue wire. So then we turned...
So it was 3.2 volts on the green wire. You've got
and just a few millivolts on the blue wire. So then we turned the Hedgehog off.
Mm-hmm.
This battery's disconnected from the circuit. And I used the resistance setting on the multimeter to check the resistance between the negative side, or the ground, and the blue wire. And it was virtually 0, indicating that they're both electrically connected. So the blue wire is the ground point, or the negative side of the battery. So
you're just double checking what it does when you press the button, so that we'll have a better idea straight away if it's working.
When we connect the sound sensor,
yeah.
So what does the Hedgehog do when you press the nose button? Its eyes flash and it makes some other sound. Is that right?
Yeah. I mean, the main reason why I wanted to be able to use my voice to control it is because while you're pressing the nose, it's not rolling forward, and it's a way to stop it keep rolling forward all the time.
Right, yeah.
Long press, you usually get a longer reaction, so like a song.
Okay, I'll give it a long press this time.
Yeah.
So while it's singing, it's flashing its eyes. So what does the short press do then?
Lots and lots of different sounds. Sometimes, I think it gives you a kiss sometimes. If they sniff, all sorts of different songs, but all sorts of different noises, laughs.
It seems when it's busy doing something, if you give it a short press, it doesn't pick the long press up. Let's give it another long press now.
Yeah.
So the long press is, 3 seconds almost? Let's time it. Right. So it's difficult to see what a short press does and a long press does, but it's obviously making it do something.
When it does the songs, like that is definitely a long press.
Right, okay. And we're not really sure if we can make the sound module imitate a long press.
Long press, yeah. It might be just short presses.
And what happens if you give it multiple short presses?
I don't know, because I've never tried that. I think it's just that sort of registering one short press at a time. Oh, it's seeing it as a long press there, isn't it?
Yeah, I did that test then to see what happens if you give it multiple short presses, because it's likely that the output from the sound sensor will give it effectively multiple short presses, because
So it
your
could
voice
read
is,
it. It could read it as a long press,
yeah,
possibly.
we don't know how it's going to read it, do we? But we will find out. So the green wire is going to the yellow wire, and the red and black wire has got to pick up the power supply from somewhere.
Yeah. So you're disconnecting the circuit board now, Paul, because you want to tap into a red wire and a black wire for the power.
Yeah.
So you're looking at the reverse of the circuit board.
That's correct. We want to tap into the ground at a suitable point and tap into the switched positive supply, so that our little module turns on when the switch is turned on. So this point here is the black wire, where the black wire comes in, so we'll tap in there. And I think this point here is the switch positive, but we'll just check that and I'll be tapping in there. Okay, so we'll turn it on. And we'll measure the voltage there. Right, so that wasn't the... so the red wasn't the switch pod, it wasn't... Right, it's the orange which is the switched positive. Okay, so let's turn this back round and put the circuit board back. So this is the ground, this is the positive. So we'll just turn that on. You can see this powers up okay. And it does. Yeah. So it's connected into the power, all right. Now does the signal wire work? So it's the green
To
the yellow. If we trigger this, if this works when we turn it on and we trigger it, how will we know it's working?
Because it will be making noises rather than trying to roll forward.
Let's turn it on. It's on. Connect the digital output to the switch input. Testing, testing, 1, 2, 3, 4.
Yes, it's listening now.
Hello, little hedgehog. Yeah, it came on because its eyes flashed, didn't it? Yeah. Hello, little hedgie.
I don't think we're getting
a long, effective long press out of it, are we?
We didn't think we would though, did we?
No, we didn't.
I think it's working on a short press, but I'm not convinced it's working on a long press.
Yeah. And I would say that's because the output of the comparator, that's why when the light comes on, isn't able to remain on constantly for 3 seconds, if that's the necessary amount. I think it looks, I mean, the light's on a lot, but it's sort of going off.
Yes.
I think it's going on and off rapidly a lot.
What would be interesting would be to let it power down, like going to standby, so you don't touch the switch.
Okay.
You don't interact with it. It goes into standby quite quickly.
Right, okay.
And to see if it would power up, because
yeah,
I think just a short press should power it up. I don't think you have to have a long press. There, it's powering down now.
Is it off? Hello.
Hey! That's excellent. That's excellent. So you can make it power up. That's brilliant.
So it is recognised in the short press.
It's recognised in short presses, yeah.
Yeah.
So that's great that you can make it up with your voice. So I would consider that a success for a short press, right?
Yeah.
Now, what we were saying earlier when we were talking, you said that to get it to work off a long press, you will probably have to make up a board yourself, or we would have to buy a different soundboard.
Yeah. Yeah, I would say so.
So that could be something we do on another project. And it would be good to have another Hedgehog and do that and then be able to compare them side by side.
So, do you think we should fasten this back together then? And
Yes, I think we should. I think we should consider that
consider
complete.
it complete for that. Yeah.
So what do you think about mounting, Paul?
We probably want to be away from the speaker, and we probably want to be away from the motor as far as possible. Maybe like that.
Yeah, as long as the shell will go on.
Yeah, the shell will go on. Okay. Just let that sit properly.
So you're going to let that tack off and glue it on, and then I could try assembling it.
Yeah.
So I've put the Hedgehog back together. All of these 3 Hedgehogs are on standby, but only the one in the middle will wake up with sound.
Shall I try it?
Yeah. So you did that with a click of the fingers. If you speak quite loud close to it, it also wakes it up.
Right.
But what we found is because of the way it's mounted and the fact that it's got like 2 shells above it of plastic and air in between.
When you say because the way it's mounted, you mean the way we've mounted the sound module?
Yeah.
And it's got these 2 plastic shells above it.
It's actually sort of insulated it.
Yeah, and it's more sensitive to vibrations than sound.
Yeah. So what we're thinking of doing is taking it apart. And what were you talking about doing, Paul?
Well, I think we should separate the microphone from the sound module itself. Have the microphone close to the front of the face, maybe close to the ear, and then make a little
hole.
Make a little hole in the ear so that the sound, our voices, can get through to the microphone, and also mount the microphone in a bit of sponge so it doesn't pick up mechanical noise and vibration, make it less sensitive to that.
If you're wondering what's happened to this Hedgehog's fur, I took the fur covering off to get a pattern because I'm going to put my own fur on, and then we're going to try and get a suitable colour to match the fur of spray paint, and we're going to spray paint the plastic. And I've decided, I was thinking, should I use silicone, should I just use latex? And I've decided to make a face, I'm going to use latex and make it like a mask that'll go over this one.
And the colouring, you're going to you're choosing something that's more sort of realistic, the browns, beiges.
I mean, it's not going to be realistic, obviously. We've woke it up.
Yeah.
Obviously, it's not realistic, but it's going to be browns rather than like a bright pink or purple or something.
Yeah. It's very good at rolling over when it's not got the fur on the body, isn't it?
Yes, ironically, when it's not got the fur on, it can actually roll and land on its feet far better than the other 2.
But it doesn't look very pretty.
Oh, no, it doesn't at all. So we'll be getting its new fur covering. So that's what we've got planned for the next project video. So, as you said, to separate the mic from the board. But you were also talking about adding another component to the board as well, weren't you, Paul?
Yeah, the component I'm thinking of adding to the sound module is just a resistor, which has a little bit of positive feedback to introduce a bit of hysteresis, which will actually make the sound module function better in this application.
Right. So, and you're thinking of doing that on this project, this particular project?
Yeah, when you strip it down again to do your cosmetic work on it, fur and paint, I can take that opportunity to modify the sound module slightly to make it function better.
It's great that the short press is effectively working from voice. Though it has to be quite loud now because of all the casement. And it'll be great if we can get that to be more sensitive by doing what you said, having it close to the microphones, close to the surface and a hole. And it'd be great if you adding this extra component can mean that the long press will be activated.
Yeah, I think we'll be able to generate an effective long press of about 3 seconds by talking to it longer, using this resistor and introducing a bit of hysteresis. Yeah.
So, folks, I hope you'll join us for that next part of this project video.